Hi, welcome to this session, and in this particular video we will discuss about several specific rules that make our life really easy when it comes to tackling the data sufficiency question. So let me quickly start with rule number 1. So rule number 1 is that the information and the results of the question and the statements can never ever contradict. By that, what I mean is that if by any chance the first statement suppose gives us the value of x equal to 2, then the second statement can never give us the value of x equal to 3. Why? Because these will be in contradiction to each other. If the first statement gives us the value of x equal to 2, then the second statement will either give us the value of x equal to 2, or the second statement will give us the value of x with 2 and some other values. But it's impossible that there is complete contradiction, that the first statement says that x is 2 and the second statement says that x is not 2. Now, this rule has quite a greater weightage in finding out the mistakes if we ever make while solving the questions of data sufficiency. Therefore, it's important that we understand this rule and we learn to apply this as well. So, this exercise has to be done in two steps. Number one, we first validate the claim of rule number 1. So, I have just collected a few official questions through which we will understand that rule 1 is true, valid, and we need to know about it. In the second step, we will learn to capitalize the benefit of knowing rule number 1. That means what benefit do we get if we know the rule number 1 while solving the questions. So that's the second thing that we will address in this video. So the first thing, let's quickly address the first point. That means let's validate the claim of rule number 1. And the claim of rule number 1 is that the information and the results of the question and the statement can never contradict. So I've kept here 3 questions, 1, 2 and 3. And we will discuss these 3 questions one by one. We'll try to understand that what do we mean by this particular rule. Let's look at question number 1. Question 1 says that does 2x equal to 2x plus 8 equal to 12. That means if we simplify it, we say that is 2x equal to 4. That means the question is x equal to 2. The first statement, when we simplify it, gives us x equal to 2. The second statement, when we simplify, gives us 40 minus 8 is 6. 6 divided by 3 is 2. That means the answer to the question will be D option, because each statement alone is sufficient. But the important fact here to notice is that the first and second statement both are giving the same value of x. Similarly, when we move to the second question, is the integer p even? So the answer to this question needs to be given in the form of yes or no. The first statement says that p square plus 1 is odd. That means p square will be odd minus 1 will be even, and if p square is even and we already know that p is an integer, that means p will be an even integer as well, which means the first statement gives the answer to the question is definitely yes, sufficient. And second statement, when we see p plus 2 is even, that means p is equal to an even number minus 2, and even minus 2 is also even. So second statement also gives the answer to the question as definitely yes, sufficient. So again, the thing to notice is both the statements are giving us the answer yes. It's impossible that a first statement says answer to the question is yes and the second statement says the answer to the question is no. Never ever is it possible. So now let's quickly look at the third question here. So if x is greater than 0, what is the value of x to the power 5? The first statement says that root x is equal to 32. That means x will be equal to 2 raised to the power 5 square, which means 2 raised to the power 10, which means x to the power 5 will be 2 raised to the power 10 raised to the power 5, which is 2 raised to the power 50, which means the first statement alone is sufficient. Now let's check the second statement. The second statement says that x square is equal to 2 raised to the power 20, which means x square is equal to 2 raised to the power 10 square, which again means x is equal to 2 raised to the power 10, and that again gives us x to the power 5 is 2 raised to the power 10 raised to the power 5, which is 2 to the power 50. The same value of x we have got from the first statement and second statement, and the answer to the question is D option. So here we have validated the claim by taking 3 official questions, but these 3 questions are of easy level. So what I'll do now is I'll quickly take a slightly harder question to once again validate the same rule. Alright, so now let's come down to next question. So the next question here is a question that I've taken from work rate. So here the question here says that working together, Rafael and Salvador can tabulate a certain set of data in 2 hours. Rafael and Salvador, these two people can tabulate the data in 2 hours. And how many hours can Rafael tabulate the data? Which means we have to find out the rate of Rafael here. Now, the first statement says that working alone, Rafael can tabulate the data in 3 hours less time than Salvador. So, if Rafael takes t times, then Salvador takes t plus 3 hours, right? So that's in the R, and we know that both of them can tabulate the data in 2 hours. That means the equation we get is Rafael's 1 hour job is equal to 1 over t, and Salvador's 1 hour job will be equal to 1 over t plus 3, and the equation that we get is 1 over t plus 1 over t plus 3 is equal to 1 over 2. Now we have to simplify this. Simplification of this gives us t equal to, let me just quickly check it up. If I take the value of t equal to 3, I get 1 upon 3 plus 1 upon 6. Yes, so at t equal to 3, we get 1 upon 3 plus 1 upon 6, which eventually becomes 6, 2 plus 1, that means 1 upon 2, satisfied. So we get t equal to 3. Now, we know the rate of Rafael as well as Salvador. That means the first statement alone is definitely sufficient to answer the question. Option B, C, and E can be eliminated. The second statement, working alone, Rafael can tabulate the data in half the time that Salvador, working alone, can tabulate the data. Okay, if Rafael tabulates the data in half the time, that means if Rafael takes t times, then Salvador will take twice of t time, right? So the equation that we get is that Rafael's 1 hour job will be 1 upon t, Salvador's 1 hour job will be 1 over 2t, the combined rate will be 1 over t plus 1 over 2t, which is equal to 1 over 2. Now we once again need to simplify this, and we know that if we substitute t equal to 3, we will have this value which is equal to 1 upon 2, that means t is equal to 3. So the second statement alone as well is sufficient to answer the question, and it's also an official question of 700 difficulty level. You see the same values of t. So even though the information has been given in different formats, the answer will always and always be in sync with each other. So the information of the question and the information of the statement can never ever contradict. So here our first stop gets completed. Now our second step is to quickly see the benefit of it. Alright, so to seek the benefit of this kind of a thing, let me just quickly bring one of the questions right here. Now that we have a question, with this question we will try to learn that how to take the benefit of it, benefit of knowing this particular rule. So what happens is that many students, while solving this question, what they do is, let me just quickly tell you, they say 6xy is equal to x squared y plus 9y, and if you can find out that what I'm doing and where I'm going wrong, I would really appreciate that. That means 6xy is equal to y taken common, x squared plus 9, which gives us 6x minus x squared plus 9 minus 9 equal to 0, which means x squared minus 6x plus 9 equal to 0. That eventually gives us x minus 3 whole square equal to 0, which means the inference we have is equal to x equal to 3. Now, having simplified the question stem, now I look at the first statement, which says y minus x is equal to 3. So I see that x is equal to 3, that means y will be equal to 3 plus 3 is 6, and what the question seeks, which is the value of xy, is equal to 18. That means the first statement looks sufficient. Now, the moment I have done that, now let's look at the second statement. The second statement says x cube is less than 0, which means x cube will be less than 0 only when x is less than 0. Now do you realize that this information is contradicting the information of the question? So here it sends us an alarming bell that see, we have made some mistake somewhere. And this alarming bell is exactly the benefit of knowing this particular rule. The moment we know we have made some mistake, we have to go back. Is this absolutely right? Then we see that no, this is not absolutely right. We have made a mistake here. The mistake is we cannot cancel out the variable like this unless we know that it's non-zero. We don't know nothing about y. So we cannot simplify it like that. So what happens is we have to take y common and then simplify the equation. So the simplification of this entire equation gives us x equal to 3 or y equal to 0. So instead of just one inference, we have here two inferences. Either y is 0 or x is equal to 3. Now with these two understandings, when we look at the first statement, at x equal to 3, xy is 18, but at y equal to 0, xy will be 0. That means while we were finding the first statement sufficient, that would be incorrect result, because the first statement is not sufficient, because xy can have multiple values. There are two values that we have been able to identify. One is 18 and the other is 0. And now when we look at the second statement, so what we understand is the second statement clearly says that x is negative, which means x now can definitely not be equal to 3, right? And the moment we see that x is not equal to 3, we understand that means y has to be 0, because for the question stem to be possible, one of them has to be true. And if y is 0, then xy is equal to 0. That means the second statement alone is sufficient, and the answer to this particular question becomes option B, because the first statement we have seen is not sufficient to answer the question, as it gives us multiple values of xy, while the second statement has led us to one conclusion, that xy value is definitely 0, because x is not 3, so y has to be 0. I hope now you understand what is the benefit of this entire exercise. Knowing this rule can get rid us from some possible mistakes. We can identify some of the mistakes on our own if we already know about this rule. I hope that makes sense and that helps you. Now that we have seen this rule, there is another bigger question comes in. So let me pose that question and then I will stop this video right here. Now what that question is, should the two statements in data sufficiency be treated completely independent? That means now that we know that the first and two statements can never contradict, they will definitely be in sync if at all they each alone is sufficient. So should we actually completely treat them independent? Now, to answer this question, you will have to watch the next video. I hope you enjoyed watching this video here. Thank you so much.